Today we're going to talk about factoring trinomials that look like ax squared plus bx plus c, meaning now that we have a coefficient other than 1 in front of that x squared. I do have the steps listed for you. Honestly, they're probably not going to make tons of sense right now. Well, they start to make more sense as we do examples, but they are there for you to reference in the future. But I will note that you should always make sure you check for a GCF first. This is always the case no matter what you are factoring, because sometimes in these cases you'll look for that GCF, you'll pull it out, and that x squared is no longer going to have a coefficient, and then those trinomials are super easy to factor. Those are the ones that we were working on the last lesson. But there are times that you're going to pull out a GCF and there's still going to be a coefficient in front of the x squared, which then you're going to need to use this alternate method that I'm about to teach you. The other major difference here is that when we did those trinomials before where there was no coefficient in front of that x squared, our goal was to find factors of c that added to b. But what's different here is we're not just finding factors of c, we're actually finding factors of a times c. So we take that coefficient, multiply it by that c. Okay, and that's our target number. Okay, so a times c, we want factors of that still add to that middle term. Okay, so example 1, I'm actually going to start with a pre-example, which is really just a multiplication question, factoring in reverse. Okay, so we have these two factors, and we're going to multiply them out. Now I am going to include an extra step that we didn't really show before, but I'm going to do that for a purpose, so let's see. I'm going to take that whole parenthesis, that second set of parentheses, and what I'm going to do is show that we're doing 2x times that whole second set of parentheses, which would look like 2x times 3x plus 1. And then I'm going to take that positive 7 and do the same thing, multiply it by that whole other set of parentheses, and that's what it would look like. So normally we skip that step and we just kind of jump right into doing this distributing, okay? And if we did that now, it would be 6x squared plus 2x plus 21x plus 7. And I do have those x terms in the middle, which I need to combine together. So my final answer for multiplying these two factors out would be 6x squared plus 23x plus 7. So now when we go to factor something, okay, it's actually going to be the same exact steps, but in reverse order. So when we are factoring, I'm going to say same steps in reverse. Okay, so we are looking at 6x squared plus 23x plus 7. Once again, that is what we just got as this. So we should end up with these two factors as our final answer. Okay, and so to start, we're not finding factors of 7. Oh, I should note, check for GCF. There is none. Okay, so now continue. We're going to find factors of 6 times 7. That's our target number. 6 times 7 is 42. So we need to find factors that multiply to 42, but then add to that middle term, which is 23. And our two numbers are 2 and 21. 2 times 21 is 42. 2 plus 21 is 23. Okay, so now we are going to take that middle term. Okay, if you kind of look back here, that last step was taking those two like terms and combining them together. So it's going to be like we're uncombining our like terms, okay? And what we're uncombining our like terms into is using these two numbers that we just decided. So that 6x squared is going to stay there. That plus 7 stays there. But we need to split up that 23x into two pieces. And those two pieces are going to be a positive 2x and a positive 21x. We have not changed what our expression equals, okay? It still equals 6x squared plus 23x plus 7. We just made it look a little bit different. And I promise you that this order does not matter. I can even go through and do it the reverse way and show you it still works. But no matter what, it does not matter what order you put these in. So now we're going to kind of split up our 4 terms. Okay, we're going to group them. And we're going to say, let's look at the first 2 together and look at the second 2 together. Okay, and we're going to focus on those pairs, and we're going to pull out the GCF from that first pair. So just looking at 6x squared plus 2x, I can pull out a 2x, which would leave me with 3x plus 1. Okay, that's only pulling the GCF out from the first 2 terms. For this method to work, the good news is, once you know what this parenthesis is, for the second 2 terms, and for here, actually the last 2 terms, okay, that parenthesis needs to be the exact same thing. Okay, if you look back at what we multiplied out up here, that 3x plus 1 was the same in both spots. So for this to work, this has to be the same thing as that. So I kind of just automatically take this parenthesis and rewrite it over here. And now I can find the missing piece that goes out front. Well, what has to go here, where now if I multiply it, I'll get back 21x plus 7. That's going to be a plus 7. And I am almost done. Okay, the one term, oops, sorry, I meant to do highlighter. Let's get rid of that. Okay, the piece that repeats, that 3x plus 1 and that 3x plus 1, okay, that is one of our pieces. And then that 2x and plus 7, that is going to be our other factor. And you can see that this is exactly the same as we started with. They are reversed, but that does not matter. Okay, so just to show you what would happen if I reverse my order here, I'm going to kind of take that step, and I'm going to do 6x squared plus 21x plus 2x plus 7. So reversing the order of those 2 middle terms to prove either way works. In this case, when I group them up into 2's, I would pull out a 3x, which would leave me with 2x plus 7. That has to be the same as this one over here, which means the missing piece to put here so that it equals 2x plus 7 would be plus 1. So the part that repeats is one of my factors. The stuff that's on the outside, the GCFs that were pulled out, is my other factor. Okay, let's try example 2. In this example, we check for a GCF, and there is one. Okay, that would be a 2. So when we do that, we have 2n squared minus 7n plus 3. So now we're no longer looking at this original polynomial. We're looking at this 2n squared minus 7n plus 3. Okay, so I need to find factors of 2 times 3, which is 6. So factors of 6 that add to negative 7. Okay, so I'm looking for 2 negative numbers, because 2 negative numbers will multiply to a positive and then add to a negative. So numbers that multiply to 6, I'm thinking -1 and -6. So we are going to take that middle term and we're going to split it up into the 2 pieces. I'm ignoring this 2 for now. I highly recommend just ignoring it for now, and we're going to deal with that later in the final answer. So I still have my 2n squared. I'm going to say minus 1n minus 6n and plus 3. I group them up into 2's, and I pull out the GCF from just the first 2 terms. So from here I can pull out an n, which will leave me with 2n minus 1. Remember, this parenthesis has to be the same for this parenthesis. So I rewrite it. And now I see what's missing. What can I put here, where if I distribute it, it will give me -6n plus 3? That would be a minus 3. So the thing that repeats, the parenthesis that repeats, that's one of my factors. The stuff we pulled out gives me my other factor. And then lastly, don't forget That 2 we already pulled out in the beginning. That does have to stay as part of the factorization. And then that is our final answer. Let's try example 3. Okay, for example 3, we check for GCF. There is no number, there is no variable in common. However, there is a negative. Okay, and we said any negative coefficients, leading coefficients, that negative should be factored out. So while we're not factoring out any numbers or any variables, we are going to factor out that negative sign, which means we're dealing with 4x squared. It's going to change the signs of everything, minus 12x and minus 7. So now I'm finding factors of 4 times negative 7, which is negative 28. I need 2 numbers that will multiply to negative 28 and add to that middle term, which is negative 12. Okay, I'm looking for 2 different signs. The bigger one must be negative. That would be negative 14 and positive 2. So I'm going to split up my middle term. Bring down my 4x squared, bring down my minus 7. Those 2 numbers we just decided on means it's going to be minus 14x and plus 2x. We group it up into 2's. We pull out the GCF. So the GCF for these is 2x, which leaves me with x minus 7. Okay. Oops, sorry. Made a mistake there. It would not be x minus 7. It would be 2x minus 7. I was trying to figure out what went wrong. Okay, so if we pull out a 2x, that leaves me with 2x minus 7, because we need the 4x squared. This parenthesis has to be the same for this parenthesis over here. And I do need to put something here on the outside. In this case, I just need to put a plus 1. So the one parenthesis that repeats is one of my factors. The stuff I pulled out is my other factor. And then don't forget about that negative. And there is your factorization. Okay, we're going to do one more with multiple variables. Same idea. Okay, just x's and y's. So here, there is no GCF. So I'm going to say we need to do 2 times negative 3. That's our target number. We need numbers that multiply to negative 6 and add to a positive 1, which would be 3 and negative 2. So we're just going to say 2x squared out front. Negative 3y squared is still in the back, but it's going to be plus 3xy minus 2xy. And so I group them up in 2's. I look for GCF. In this case, I can pull out an x, which would leave me with 2x plus 3y. This has to be the same for the other one, so I'm going to rewrite it over here. Okay, and then what we are missing then is a negative y, because negative y times 2x would be negative 2xy. Negative y times 3y would be negative 3y squared. What repeats is one of my factors. The stuff we pulled out is my other set of factors. Okay, I know this one is a little bit harder. I do have a worksheet that will hopefully walk you through the steps a little bit more before you kind of jump in and try them on your own. But as always, if you have questions, please make sure you reach out and ask me.